Namaste guys, in this video we are going to learn how to create this intermeshing rotor helicopter blade design in Solidworks. So without wasting any time, let's start. So first thing you have to do is go to the assembly mode. As you can see, I am already in assembly mode. Okay, now let's try to start make it. So before I make it, some sketch I need to make just to know that I saw this mechanism on Pinterest and I am making live in front of you. I never made this design from anywhere. I don't know what is dimension. So whatever I'm making live in front of you. I don't have any idea, even a single line dimension, what is going to make. So I'm just going to, make with the flow. So first thing that I'm going to make is gears. So instead of making gear from your hand, just go to the ANSI matrix in toolbox. If you go to design library, click on toolbox, go to the NSI metric. Remember, I'm choosing metric because I'm familiar with it. If you are from America, you can use inch pound. Again, up to you. Now go to the gears. First thing that I'm going to use is my spur gear. So I import a spur gear. Okay, its module is 1 and number of teeth is 30. Click OK. Close it. Okay, again import another gear, but this time the number of teeth on this gear is high. Let's make it 40. Okay, and click OK. Close it. Now first thing that question arises in your mind, so how we can place these gears and other stuff. So let's see. So select the top plane, click on sketch. Okay, so as I know this gear has a number of teeth 40 and module is 1, so it means the pitch radius is pitch circle diameter is 40 as well, so 20 is the radius. So okay, simple maths. If you had read the chapter of gears, then you will know what I'm talking about. If don't, I highly recommend just go to theory of machine chapters. You will understand what I'm talking. So enter the value of 20 and exit the sketch mode. After that, select this, and by pressing Ctrl select this line, make sure it's concentric. Okay, and select this face and select the, let's see which plane we are talking about. Select the right plane. Sorry, by pressing Ctrl select this face and click on coincide. Okay, now move this teeth gear below. Select this one. As you can see, I am not able to move it. The reason is that, as you can see, a message pop up. The component is fixed, it cannot be moved. To move it, right click on it and click on float. So if I select this, you can see I can see this and I can move it as per my requirement. Now before I do any kind of changes, first thing that I need to do is go here, click on show the sketch. As you can see, I can see this line. So click on mate and this line, uh, click on distance. As I already told you, 40, so enter the value of 20. uh, Enter the value of 40, sorry, not 40. Okay, wait a minute. uh, 20 plus 15, that is 35. So basically what I'm talking about, 20 is the pitch distance from here to here, and this gear has 30 teeth module 1, so 15 from here. Okay, that is the reason 35 comes out here. Click here. After that, let's move it here, and what I want, select this line and select this line and make it parallel. Click OK. Select this face and by pressing Ctrl select this face, make them coincide. Click OK. So you can see I have made the gear. Now before I move forward, one thing that I will do is go to the mates, go to the mechanical, click on gear, remember gear, and select this. Okay, instead of 10, enter the value of 40. Select this. Instead of 10, enter the value of 30. 30 is the number of teeth. Click OK. Let's see if it's working correct or not. Here's a problem that this gear is moving. So what I can do to make it fix? So I need to create a sketch again. So let's see how to approach this problem. uh, so what I will do, go to the sketch. Before I create a sketch, let's create a plane so that I can correctly place. So click on reference plane, and select the front plane. Enter the value of 20 mm. Click on flip offset. Click OK. After that, select this plane. Click on sketch. Sorry, exit the sketch mode. Exit. I want to select this plane. Click on sketch. Now draw a line. Doesn't matter how long it is, just make sure that it passes through the origin. Okay, it's longer than this line. Now the distance is 35 mm. Cancel. Select this and this. Okay, why it's not picking the, select this line, and this is the origin. The dimension is already made. Okay, press Ctrl 8. Exit the smart dimension mode. Select this. As you can see, some constraints are already made here. So what you have to do is select this and delete. Now I can move it freely now. Now go to the sketch, select this and this, enter the value of 35 mm. Click OK and exit the sketch mode. After this, what we have to do is go to the mates, select this circle and select this line. Make sure it's concentric. Click OK. Add this make break. Just do it. We will see what kind of issues we have. So if I try to rotate it, it can't rotate. So one issue is that 35 mm sketch. So right click on it and delete this constraint. The reason is that I don't need a constraint because I already use this sketch, so it is over defining the sketch. That is the reason you got the error like that. Okay, so I have made it. Now one thing more you have to do is select this and press F2 and type 40 mm gear distance, so that we know what is this sketch for. Okay, select this power gear because this gear will transmit the power. Okay, so select the sketch, click on sketch again, but this time the distance is greater than 20. It is 20, sorry, it is going to be 20, not greater than. Or you can just choose cancel it, delete this 40, click OK and exit the sketch mode. Now what we can do is, by pressing Ctrl and left click on your mouse, drag this part and go to the mates, select this and this. Make sure it's concentric, click OK. Select this and this, click OK. Select this face, press Ctrl plus 8. As you can see, these gears are not correctly aligned, so move it. Now what we have to do is go to the mates, go to the mechanical, click on gear, select this and this. Now click OK. A question arises in your mind, why I am not changing the teeth diameter and other. The reason is that I just need to know the gear ratio. It doesn't matter whether it is 100 or whatever. The main thing that is matter, that make sure that gear ratio is correct. Okay, in my case gear ratio is correct. It is 1:1. So yeah, it will not will cause a problem. As you can see, it's working smoothly. Okay. Now what I have to do is, now I need to add basically two uh, bevel gears. So drag and drop it. Again, module remains once, and make sure, remember, listen carefully, make sure that the number of teeth on here and the pinion is same. If they are different, the mechanism will not work. Okay, so make sure you don't do this mistake. So go here, let's increase the number of gear to 30. And similarly here 30 as well. Okay, now the hole is looks small, so I will go downwards and find the hole diameter. Let's enter the value of 20 mm. I guess I choose the diameter is not the property. Where is the diameter? Is this one? Let's see. Wait a minute. Let's find out. As I told you earlier, I am not a pro as well. So let's see where is the hole basically. Here is the normal shaft diameter. Increase value to 10. Okay, this looks fine. And mounting distance to 30. Okay, this moves out a bit. Let's instead of 30, let's enter the value of 20 because I don't want it, to move out. I want to attach it with here. Okay, so I think that looks fine to me, and it's okay. Click OK. We need four parts like this, so just simply click on the workspace and click close. What we are going to do, first go here and hide these sketches. Now go here, meet. Before I do meeting, select the part. So select the part from here and rotate it. After that, go to the mates, select this face and this face. Make sure it is coincide plus. Make sure it is log rotation. If you forget to add log rotation, you will do a major mistake. Before I do that, let's do one more thing. Uh, Select, just move it aside. Go to the mates. I just want to make sure that the face is also completely attached with it. So click OK. Now, I'm going to do what I was telling. So select these two faces, make sure it's concentric, and click on lock rotation and click OK. So if I try to rotate it, okay, here you can also see from here. You can see this gear is also rotating, and this is basically what I want. Now what I can do is, uh, before I move further, I need to create a basically sketch to make sure it is inclined. So how can I do that? So to do that, first select this gear, uh, go here, and I want to see all the sketches. Not this one. Yeah, this one. Right click on it and click on show. Remember, I'm click on show. Okay. So let's first measure the distance from here to here. So go to the evaluate, measure. Again, I'm saying that I don't have any dimensions or clue. I'm just making, for my imaginations. So don't ask for me where are is drawing, etc. So it's 30 mm, as you can see, this purple line 30 mm. So I need to create a plane 30 mm from here. So what I can do is go to the assembly, plane, plane, select this face, enter the value of 30 mm, click on flip offset, click OK. Uh, Select this plane, press F2, and give it a name, inclined gear plane. Okay. Now what we are going to do is right click on it and click on sketch. So it's up to you how much inclined angle you want to give, because even I don't know. As I told you, I just saw the mechanism on Pinterest, and I think, hey, this looks cool. So let's try to see what will be the right angle. And I think 20 degrees fine. Again, I don't know what will be the exact right angle. So click OK. Now what we can do is uh, select any gear you want as per your requirement, rotate it, and let's move this up. Now what we can do is go to the mates, select this point, remember point, and select this point. Click OK. After that, select this sketch and select this line. OK. Now click OK. As you can see, this gear is not correctly aligned, so align it. The reason I made this sketch so that when I rotate this, it will not do some error or unwanted results. Just in case if you want to learn about Solidworks animation and motion all this, I highly recommend check out my course, link in description for better understanding what I am saying. Now one thing that I will do is I have to define the gear ratio. Again go to the mechanical, click on gear, select this face and this face. As you can see, T diameter is 15-15. Oh, it's okay because the gear ratio in that case is also is 1. So I don't need to worry about what will be the T diameter. Main thing that is important is the gear ratio. Click OK. So let's see if it's working. So if I try to rotate it, you can see it's rotating and it's quite good. Now a question is how to make this part here. I will try to use mirror component. I don't know it will work or not, but let's give it a try. So click on here, click on click on mirror components. Now select the plane, select the front plane. Sorry, I have to use mirror components. So where is the mirror component? Yeah, mirror components. So first thing I have to do is select a plane. Remember I choose this front plane as a standard. That is the reason at the beginning I have defined the sketch distance 20 mm from the plane. Okay, that is the reason that I choose origin and distance 20 mm so that I can use mirror command later onwards. Now it is asking for the components to pattern. Select this and this. Remember I am not sure whether it will work or not. So let's see. It's look good to me. And click OK. Okay, it's again looks good to me. Now let's see it's working. Yeah, it's working fine. Hey man, looks good. Great, you know. It saves me a lot of work and effort. Else I have to create, again sketch, blah blah, done things. Now, other thing that I have to create is I have to now create fan blades. After that, we will work on the base part. Okay. So to create fan blades, I will not do any kind of hard work. What I will do, I will simply create a shaft and create a blade on there. Okay. First, let's remove these annoying sketches. So go here, right click, click on hide. Okay, I accidentally choose a Spurgia, but I actually want to use Spurgia, this one. So my bad. Right click. Okay, now this one. Which one it is? Hide. Yeah, we have done hide it, and accidentally we activate this gear. So let's hide that. Right. So yeah, we are now. Let's create the other part. So we have to create a shaft and blade. So let's see how to approach this. So go here, click on new part, select the front plane, press Ctrl plus 8. So if you remember correctly that I created the shaft diameter for basically 10 mm. So what we are going to do is let's make the 10 mm. Basically you have to make 9 point exactly in real life, but I'm just doing for teaching purposes. So I'm not going to think about highly accurate etc. like thing. 5 mm is the radius that is going to use, and after that we will use circle extrusion. Enter the value of 70 mm. Press escape, select this point and the origin. Make sure it's coincide. Click on here, click on revolve workspace, click OK. Now next thing I have to do is I have to make the blades. So let's see how to approach this. My PC is quite getting warm up. I don't know whether you are listening or not. So select this. Now door starts sparking. And let's go here, click on sketch. Extrude as per your requirement. I think 175 is fine. As you can see, it is quite small, for that. It is just for education purposes, nothing, rocket science. Go here. I can make it accurate as well, but again, nobody likes to watch long videos, so I don't make them. And guys, subscribe. Don't make me broke. Let's use another one. Select this. Add features. Select this one. I will just going to use two blades. Click OK and exit the assembly component mode. Now what I'm going to do is select this part and move it. Go to the mates, select this part, select this and click OK. Similarly, just move it for a bit. Click here and here. Okay, I have done a one mistake. The mistake is that when this gear will rotate, it will not rotate this one. Let me show you what I mean. As you can see, I can rotate, but this fan blade is not rotating. So it is not correct. So what I can do, select the blade, go to the mate, right click on concentric, click on edit feature. Just click on lock rotation and click OK. Now, if I try to rotate this, you can see blade is also rotating. Now, as again we are lazy guys, we are engineers, we don't do hard work, so we will go to this one and click on plane. Don't choose this clear selection and select this one. Click next. Okay, we have problem here. So how to resolve this problem? So simply what you're going to do is by pressing Control and right click, drag this. Go to the mates, select this and this. Make sure it is lock rotation. Okay, and click OK. After that, select this and select this face. Click OK. Before I do lock rotation, I have done a mistake again. What I have to do is go to my mates. This is the rotation. Right click on it and uh, right click on edit feature. Just uncheck the lock rotation for a minute. Okay. The reason I'm doing that, I want to basically place orient this is correctly. So let's see what will be the right orientation. Let's move it a little bit forward and cancel it. Right click. One thing that you might notice, when you click on lock rotation in concentric, there is a dot filled. As you can see, there is no filling. It means it is not a lock rotation. Small detail, but yeah, it's make a huge impact. So if I try to rotate it, we are not interfering, right? Okay, to this point is okay. Now let's make the casing of it. So let's see how to approach the casing. So before I move forward, select this and press F2. As you can see, there is a traffic icon. It is called rebuild icon. Click on rebuild, select this part, press F2 and let's call blades. That's okay. After that, we will make the casing of it. So to make the casing, click on create new part. Let's see what is the right plane. Right plane is the right plane. Press Control plus 8. Now I have to make the casing of it. Let's see how I am approaching this problem. So go here, click on center rectangle, click here, smart dimensions. Let's make it 20 mm. The distance here is 90. I don't know whether it's you can make it in reality. These kind of helicopter are available in the market, or I think they are not working right now because they have some issues. You can Google it. Okay. Now we have made up to this point. Now how can we move further? So what we can do is go here, click on extrude features. Now what we can do is click on thin feature. As you can see, now this is we can do casing. Click on reverse direction. But I also want something from here. So click on direction 2. Let's enter the value of 20 mm, and here we will enter the value of 100 is fine, I guess. 100 is too big. Let's say 80. Not 80. Let's say 50. Okay, 50 looks okay to me. Yeah, it's okay, I guess. Click OK. Uh, After that, select this face, click on sketch, and draw the point rectangle like this. And we will also draw some circle here. Go to the features extrude. Let's make it 5 mm. Click OK. Similarly, like this. Click on sketch. Um, like this. Draw a circle. Or if you are a lazy guy like me, click on convert entities. Select this and this and this. Click OK and extrude. I just want to know there are more than one ways to make something in life. So this is what basically approach I means. Now how can I extrude it? So to extrude in this way, how you will approach? So select this face, click on sketch. Uh, let's see. I don't know whether this will work or not, but let's give it a try. So like create a circle like this. But you will guys say, hey man, you need to extrude in this direction, and swept will be the best command. Let's try the extrude command, and it's like this. Oh yeah, it's working. I think most people will find this is a new thing that you can use this kind of thing. But yeah, I love this. Notice something that after, okay, I press Control Z. Uh, here we have pause, execute pause space, and thin feature. Let's say it is 3 mm. I don't want to know. Let's just like this. Yeah, it's in that way you can make this as well. Click OK. Your selection external references because of current selecting. Okay, so it's drawing out loud. Oh, first works. So what thing we can do is select this face and select this. Click on convert entities. Not the right one. Press Ctrl Z. Select this face. Right click. Okay. First exit the sketch mode. Select this face. Click on sketch. Now select this edges. Click on convert entities. Now go here. Click on extrude cut. Select this and we can't select this line. some reason. Select this line, click on reverse direction and click OK. Okay, I don't mind that. Now what we can do is go here and mirror will work fine, I guess. But just to note that you need to go to the components, select this, features to be mirrored. I want to mirror this extrude feature plus I want to mirror the extrude cut feature. Right click, click on delete because I want the did I use pose extrude there as well? Click OK. So this is how it looks like. Exit as some component mode, right click on it and let's change this transparency like this so you know we can see what's going on inside. We can enter a shaft here to support this. So let's create some shaft. So select this face, exit the sketch mode first. Click on here, click on new parts. Select the right plane because it is a right plane. Go here, extrude. How much extrude you want to do? Section 2. Click OK. Exit that assembly component mode. What we are going to do is by pressing Ctrl and Alt key for mouse, drag it. Similarly, by pressing Ctrl and Alt key for mouse, drag it. Go to the mates, select this and this one. Okay, one issue here that this part is moving, so I don't want that this part to move. So right click on this part, click on fix. So this part will not going to move from now on. So go to the mates, select this and this face. As you can see, select this face and select the face. Click OK. Similarly, select this face and this face. Okay, click OK. Select this face and this face. Select this face. Click OK. Now to make it rotate, what we can do is, for the sake of simplicity, right click on it and click on hide components. It is temporary, I show you. So click on motor, select this face from inside uh, and let's give 100 rpm or let's say 30 rpm because high rpm will going to burn down my computer. Let's say animation is 30 fps. After that, what part we have hide, right click, click on show components. Let's make it down. As you can see, it is not a very high animation. Now click on calculate. As you can see, this is a properly mesh. One more thing that you notice that look like the gear is not correctly working. The issue is not in the basically simulation. The reason is that my FPSs are low, quite low for 30 FPS. That is the reason you are seeing the issue. So right click on it, click on edit feature. So let's instead of 30 RPM, let's say 10 RPM. And instead of, let's make it 10 seconds. And let's make it 50. Click OK. Click on calculate again. I hope now the simulation will look more better than before, but still let's pray for it. Okay, one more thing that I've done wrong is notice that this point, so basically it means that I have changed my from here basically my rpm is 30 rpm, but after here onwards it is 10 rpm. So it's a mistake from my side again. So what we do, go to the back, right click on just right click on it and click on delete. Right click on it, make sure that you have 0 seconds. So right click on it, click on edit feature, and make sure it is 10 rpm. For those who don't know what the hell I'm talking about, I highly recommend check out my course on Udemy. It will also help me, financially. I will be thankful if you anybody do. I am a pro, guys. So now you can see it looks fine to me, and blades are not also, not colliding with each other. And right click disable playback. So this looks great to me. Let's see which is the perfect. See second front view is not that. Is that view is okay? Not all things are shown here. I mean, I made years. I think this view is fine. And now you just, adjust your gear views as per your requirement. So that's for all I think in this video and nothing more. So thanks for watching and have a great day. Namaste.